Hello everyone. I am Aditya Prakash, and today we'll be talking about Ansible. Thank you everyone for joining. Most of you might not be aware of this tool, Ansible. Even we were not aware of the powers of these tool, but we have started leveraging it now. The advantages this tool is providing us. So, uh, just again, the topic for today is Ansible, simplifying infra and configuration management. So to begin with, let's dive into the problem statement that the DevOps team at GeekYants we were facing, and now Ansible has made our life easier by controlling the infrastructure and configuration. So let's quickly dive into the problem statement. So first of all, what usually used to happen in our organization is that whenever a project used to come in, the infra part we were deploying it manually. And also the configurations that we were doing on the servers or web particular, services or Docker containers, that was much of a manual process. The only part that was, automated was, the CI/CD pipelines. Apart from that, most of the things what we were doing here was the manual part. But using Ansible, we are trying to gradually discard any and every type of manual process that comes in the way of deployment. So our first target was to find a tool that does infrastructure management and another tool that does configuration management. I'll come to the definition of these in a while. So what we found that Ansible is a tool that was solving both the problems for us. Second thing, it has a huge community. It's a very old tool and a very reliable one. So this is helping us at GeekSpeak to improve our DevOps standardization. Second of all, when a developer sometimes comes to us to deploy a very basic application, which sometimes takes our bandwidth, and it's so easy that even the developer can do it. But the developer has little or less knowledge on AWS or other cloud platforms. So using the templates that I'm going to show now, maybe we'll also push some of these templates to a public GitHub account where you guys can access it. And by changing few of the env variables, you can boot up your entire application. So all you need to focus is on coding, and the DevOps part will be handled by you only, but with the help of the Ansible tool. So, and also lastly, Ansible tool is present for every and any type of cloud service providers, be it Azure, AWS, GCP, Vultr, anything, any deployment strategy you name, and Ansible has, the code present for it. So let's quickly dive into the next part. So what are we using Ansible for as of now? We are using Ansible for infrastructure as code and configuration management. So infrastructure as code, if I try to explain it as to what is written, it's a code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. So to explain it in simpler words, what I would say is whenever an architecture comes to us, be it on AWS or on bare metal, whenever something comes to us, the deployment part of it, we will not do it manually. Like developers, we will simply write a piece of code. We'll run the CLI command with our credentials, and the same infrastructure, whatever code we have written, gets displayed, or gets booted up onto the cloud on which we want to deploy it. That is the infrastructure as code part. Next part comes the configuration management. So configuration management automates the mundane maintenance tasks and frees up dev time for actual programming. It's usually used by the IT team. Say, for example, you have hundreds of servers and you want to run security patches on all those servers. So rather than, going manually and doing it, or creating an entire SSH scripting from your end to run those security patches or installation of certain packages on those servers, Ansible provides its own configuration management techniques. So you can just say, for example, you want to install Node. So you simply said, very simple YAML file you write. I'll show you a few examples in the live experiments. So you simply mention the node and the version that you want to install, and you give the server IPs. And from the system, which will have the SSH access to those servers, you will be able to execute all the commands remotely on the multiple servers with, least to no effort. So how Ansible works. So for configuration management, I'm explaining the second part first, because mostly Ansible is known for its configuration management techniques than its infrastructure as code part. So for configuration management, it's very simple. All you need to have is a basic SSH connection to any server you want to run a script on. and you simply execute the the Ansible code, and whichever server you mention and those servers you have SSH access to will have those commands executed on them. Secondly, for infrastructure as code, there is no concept of SSH here because you are deploying the infrastructure and you are not updating anything. So for, say infrastructure as code, Azure simply calls its APIs, and from its APIs, it goes ahead and, deploys your infrastructure. We'll be doing, 3 small experiments in this session. 2 for configuration management. First being a very basic Nginx deployment. Then we'll do a little complex infrastructure as code. And on that AWS infrastructure, we'll be deploying a normal CRUD application. So let's go into the next part. Before we go, let's look into Ansible terminologies. This might be a bit confusing for you guys right now, but as we proceed with the hands-on part in this particular session, things will get more clear to you. So first of all, to begin, whenever I say that we execute Ansible code, so the code that gets executed is the playbook file. Playbook file is the the entry point for the Ansible code, wherein you mention whatever things you want to run. Now, how, say for example, you have hundreds of tasks. So how will you define those tasks? You define those tasks using the task block that is given by Ansible. Those tasks are grouped together in a role, and those roles are grouped together in a playbook. Now, 2 other things that are left, that is inventory and handlers. So what is inventory? Inventory is where you mention the servers on which you want to run those commands or the roles or the tasks. And lastly comes the handlers. Handlers are a type of tasks only, but the only work the handler is doing is it's stopping and starting an application. For example, you have an Nginx package installed on Linux system, and if you want to start, stop, or restart that particular service, the handlers come into picture. You simply notify a handler to go ahead and change the state of a particular package running, and it will go ahead and do it. So this is what I explained, how basic configuration management in Ansible works. You have a management node present. You have your host inventory files wherein you mention the IPs and the server information on which you want to execute your playbook files. Playbook is where you write your main code. And if that particular management node has SSH connection available for a particular server, it will go ahead and execute the commands written in playbook onto that particular server. So let's maybe do a quick demo onto this. So what I have, I'll quickly show. This is a normal VM or a DigitalOcean droplet, a new, very new droplet. This has nothing installed in this. I'll quickly log in and show it to you that it's pretty much empty. There's nothing installed. Top command also, I'll show that no major process is running here. And if I, exit this, I hit the IP, you will find that nothing loads. This is a very new server, and with the help of Ansible, what we'll be doing is, maybe installing Nginx on this, and the Nginx web page will load here. So I'll quickly jump into the code part. I'll again explain the different components. Here you can see this is my main playbook YAML file, which I'll be executing. So this tells me that I have to execute it on all the hosts. Now, where do we get the hosts from? We have this in the inventory YAML file inside the environment folder. We can add hundreds of servers here. That's not a problem. So what we'll do is we'll replace it with the IP of the server we have right now. Now we again look at another components. Become yes means the commands on the server has to be executed with the root privileges. And then we call the boot Nginx role. So we go into roles. This is how we, create sub roles and nested roles inside the roles folder. We go inside boot Nginx, and we go inside the tasks and main YAML file. So what this main YAML file is doing, as you can see, this is pretty simple. It's easier than the Linux command that we write. We say that you use the apt package manager, look for a package called Nginx and make its state to be present. That is, install it. After that, you have to notify a start Nginx handler. And then we call the handlers using the flush handlers block. So now because we have notified a handler, we go into the handler And we see that in the handler, we have all the things defined. That is, how do we stop it, how do we restart it, and how do we start it. So this is nothing. This is just finding a service with the name Nginx and changing its state to whatever it is written, whichever handler is called. So how do you execute Ansible playbook? First of all, you need to install the Ansible playbook CLI onto your system. Once that is installed, I have the command present here with me. Boot up. So I've defined the Ansible playbook CLI to be used. I have given you the inventory YAML file that has to be called. Inventory YAML has all the which user to be used, which SSH port to be used, and which particular host needs to be selected to run the commands on. So now I execute this. So this will go into the server, and you can see the logs here as to how it's installing. See, it has gone into the boot Nginx task. It has gone into the boot Nginx task where it's installing Nginx right now. It takes some time because it's running the shell commands onto the Linux server. And you can see we haven't remotely logged into the server. Now, if I go to the server, I do a systemctl status Nginx. You can see Nginx is active. To make it more visible, I'll go here and I'll reload the page. You can see that Nginx is very much installed onto this server. So this is a very basic playbook which we have written. It becomes more complex, when we are deploying infrastructure and the code within the same folder. It's a very basic one. We have simply installed Nginx. Now, maybe you have understood what is the role of inventory, what is the role of tasks, and what is the role of handlers. And also the VATS folder. VATS folder will come in picture. I did not need this in this particular example. And the playbook YAML file. Now, let's quickly move back to my presentation. Now, we'll be using Ansible for, infrastructure as code. We'll be deploying an infrastructure with all the network part as well. See, because for this, you need a bit of AWS knowledge. But still, I'll give you few points around so that you can relate it with when I'm executing stuff. First of all, in AWS, we create a VPC. This is the green boundary. That is the virtual private cloud. So whenever I create an account and I create a VPC, in the entire AWS cloud, it creates a small portion and associates that particular portion to my account. So this is the particular VPC which I'll be booting up. Inside that particular VPC, I'll be booting a few availability zones. Availability zones is, for example, India will be having few availability zones or data centers where, our database or the servers will get deployed to. Also inside that, for security purpose, we'll have a private subnet booted so that nobody can gain access to our database and the EC2 servers, just by bypassing the firewall. And also, there will be some components. For example, when I need to connect to my EC2 here is the server in plain terms. And RDS here is the database. ECR here is the container registry wherein we'll be pushing our Node.js CRUD application Docker image to. So this is the particular EC2 image. EC2 image might require internet access because I'll be accessing it from my Mac system right now. So for that, we need an internet gateway and a route table. So what internet gateway will do, it will give my EC2 instance access to the internet, and whenever data is flowing here, for proper communication and translation, we have a route table present here. So this is the basic architecture I'll be booting up right now. So now, if we go to the second part, the demo part. So let's, break down the architecture first. So first, I'll be booting the VPC and the network components. So if I go back to the diagram, you can see I'll be booting the VPC. I'll be booting the availability zones. I'll be booting up the route table, the internet gateway. This is all the networking part. And also all the firewalls in place. I will boot it now. After that, I'll let's boot this first before we move on to the next step. So again, to explain, you don't need to set up the route tables and internet gateways every time. You can use the default ones that AWS provides you as soon as you create an account. But just for demo purpose, to make it more complex, and for other people also who are from the DevOps field to more relate with this, I am implementing everything from scratch. So now if I go to my code, so this is the code I'll be using. I'll explain the components before we start deploying the networking part. So this is the playbook YAML file that I'll be executing. And what I'll do is I will boot all the required network components. That is the VPC, the internet gateway, the route table, subnet, security group. Security group is nothing but the firewall part. The subnet group and RDS also I'll comment out right now. So this will call the particular roles. Now where do we get the roles? We get the roles inside the roles folder. We go inside create and see VPC. You can go inside VPC and you can see the entire tasks and the roles present here. So simply I call, simply write the keyword here that will call the AWS EC2 VPC net API. And I simply pass my fields here as to what is the name I want. I want this to be present, that is to be created if it's already not there. I want to attach few network components here, that is the CIDR block. And to create this, I pass my access key and secret key of my AWS account. Now you would see that these are variables. So where do I store these particular variables? I go inside the vars folder and I go inside the infra vars. So in the infra vars, you can see I have mentioned that the name of my VPC should be my VPC and the CIDR that needs to be attached. I've mentioned a subnet block here. And also I have mentioned my access key and secret key in this particular application and the region in which I want to, go ahead and deploy this particular infrastructure. So now what we'll do is we'll open Infra playbook again and we'll deploy. So right now, as soon as this deployment completes, you'll have the entire networking part set up for you. So let's deploy this. Again, we don't need inventory here because we are deploying infrastructure as code. So we don't need to specify any server IP. We'll simply add a -e flag and we'll call the vars folder, and vars folder the particular YAML file that has the value of my variables. So I'll go ahead and deploy this. So you can see it's creating a VPC right now. It's creating the internet gateway and gradually it will create everything. It's creating the security group for EC2 and RDS. RDS is nothing but the MySQL database, which I haven't booted right now, but I have the firewall and the security principles in place. So now if I go back to my AWS account, you can see no instances are running, but I go back to my VPC. I open the VPC and you can see my VPC is booted. And if I go into the resource map, you see that my VPC is booted. I wanted to boot up 2 subnets. Those 2 subnets are booted in different availability zones. A route table is booted. And also this route table is connected to an IGW some ID. This is the internet gateway that will provide internet to my virtual private cloud. Also to go, because see, and also whenever you want to look into the information of the resource that is booted, on your AWS account, you can simply add this particular block, main YAML, maybe whatever the VPC that is created will get stored in a VPC variable, and that VPC variable with the help of debug function can be shown on your terminal to get the information. So as if I go to say maybe internet gateway, I can show you that for VPC I got a particular output of JSON object, and for that JSON object I need to tell my internet gateway that it has to get attached to which VPC. To that I pass my VPC ID that was created prior to this internet gateway. So whenever you are booting it, you need to take care of the order in which you are booting the resources. So now we have the the networking part all set up and ready. So now we'll move into the simpler part. Like for example, we'll boot up a MySQL database. So let's go into the roles of the MySQL database and look into this. So what I do here is I create an RDS instance. I pass a few variables as to what should be the type of database, that is whether it should be MySQL or Postgres or MongoDB. I pass my keys, the region, and also the subnets that are created earlier. I pass those subnet groups names and IDs, the retention period, and also the username and password. So if I go to my, the vars folder, You can see for RDS, I've passed that this should be my instance name. My DB engine should be MySQL. This should be the credentials, the version, and how much GB of space I need, what should be the tier in which the database should be booted, and the subnet group that needs to be created and attached to it. So now if I go to the RDS part, and also what I do in RDS is I create two databases inside of it. With the help of these credentials, I create a table foo and a table var, which I'll be using, when I'm running the CRUD application. So let's execute this. I'll quickly check if my playbook has the RDS part ready. Yes. So I'll quickly go ahead and execute this. So whatever things that are already created, the creation of those things will be relatively faster, because Ansible in its configuration will keep a history of instances and resources that it has already booted. So now if we go down, we see that these parts were already created. The creation of this is relatively faster. And now we see if it has already created the RDS for us. We can see that we have an active database present. So inside this database, now we can, store our data by running those SQL queries. So now after this particular database is ready, the second stateful important thing what we need is the ECR. ECR, if I go to ECR, it's the Elastic Container Registry that will store our Docker images. So I go into repositories, and you can see that no repositories available here. So I'll again go back to my code. I'll call the ECR roles. Inside the ECR role, I find that I have created the ECR repo with a particular name and my credentials using which the ECR repo will be deployed. So now I rerun the file again. It takes some time because it goes through the history and checks that whether it has already deployed few things or not. You can see the ECR information is here that no tasks have failed or skipped. So we go back to our server, we do a quick refresh here. Okay, so it was created in the private one, not the public one. So we have a test ECR present here. Now that we have all the stateful things present, the next most important thing what we require is a server on which we'll deploy our Docker CRUD application. So now we come back here, we'll call the last instance that was left, that we'll call the create EC2 role. This EC2 role will now call this particular task, wherein what I do is first I create a private key from my local system. This key will be used to SSH to log into the particular server using the SSH protocol. Now I simply now create the launch EC2 instance role, wherein I attach all the required security groups and the subnet to this. After this is done, we'll execute the command again. The EC2 instance will take some time to get deployed. I'll open EC2 here to see if the deployment will begin. We have no instances running right now. Now it's creating the EC2 key pair, and now it will launch the instance. So the instance to get provisioned will take some time. Keep refreshing. And you can see this is in the pending state. So it will take about around 3 to 4 minutes for this to get provisioned and AWS to allow us to start using it. In the meantime, we'll set up the application part. So what I'll do now, I'll go to my Node.js application. So as you can see, this is a very basic application, CRUD application that I've created that will simply go and talk to the particular database and will apply the operations. So now I'll go back to RDS. I'll get the credentials from here. Credentials as in the connection URL. This is my URL. I'll go to the env part. I'll replace the env. And also, just to be clear, whatever this is the manual thing I'm doing, which is the creation of the env, and I'll be pushing some Docker images right now. Also, I'll be pushing a small schema SQL, a small dump to my database, because I don't have a running migration or a pipeline right now. I did not want to make it very complex for this particular session. So I'll be running few things manually, but we have to keep this in mind that all these parts are automated when we are doing a production deployment. Everything, whatever manually I'm doing right now, is part of a CI/CD pipeline. So right now what I'll do is I will push this particular SQL file to the database in the foo table. In the foo database, I'm so sorry. Now I'll execute this. I'll pass my credentials, and the data is now imported into the RDS instance that we had booted. Now what we'll do is we'll quickly go through the Docker file. This is a very simple Docker file wherein we are defining a work directory. We are copying everything inside the Docker file. We are doing an npm install, exposing a port, and simply running the node app.js command to execute the application. So now what we do is we'll go back to ECR. ECR will provide us with the Docker push details. I'll go to SDCS view push commands. I'll do a quick login here. Login succeeded. Will build my image. Image is build. Tag this. These are very basic Docker commands. Docker push. I remove this. I run a refresh here. You can see a Docker image to the repository with the latest tag has been pushed. This is the Docker image of this particular Node.js code. Now we'll quickly review if my EC2 instance is booted. You can see that nothing has failed and all my 19 roles and tasks have been executed here. So now I go back to EC2 to review if everything is properly. You can see one instance is running. What we'll do is we'll connect to this particular instance. cd.sh. I'll log in. You can see a brand new server is ready for us and nothing is already installed on this. See, only one history command. No major processes also running here. Now what we'll do is we'll move into the booting of application part. That is the configuration management. It will be a bit more complex as to what we did in Nginx. So now let's come back here. Let's close everything and again start understanding from scratch the configuration management part. So for configuration management, we'll be calling our boot app playbook part. So what this boot app playbook part will do, it will log into the server again, as I said. It will do some basic setups like installation of, say, maybe Node.js, which is not ideally required because we'll be running the Docker image, but it will install some basic Linux packages like Vim, curl, unzip, those things. So now if I go to roles, you can see I have a setup folder, a basic setup folder, which has all those things present here. This will be a bit of a time-taking process, so guys, kindly bear with me. We have a Docker setup. So what this Docker setup will do, will install all the Docker dependencies. We have an AWS setup. So what this AWS setup will do, it will do a quick AWS login using my credentials onto the server so that I can perform AWS CLI functions. And the last part is the Node app Docker part, which is, we'll go to boot app, Node app Dockers, the main YAML file. This will do nothing. It will do an AWS CLI login. It will pull the image and it will deploy this particular image based on the commands the docker deploy container command, which I have got it in my vars folder. I have all the credentials present here. So now if I start deploying this, first of all, I need to get the IP of the server to be added into the inventory like we did earlier. We'll copy this IP and we will change the IP, and also we'll give the path of the AWS private key file using which my Ansible will log into the server and execute commands. So now if I do boot up, you can see I have passed using -I have passed the inventory file. I see that the environment vars file is missing here. So what I'll do is I'll do vars/ the name is boot app vars YAML. Boot. Yeah. Secret. This is a time-taking process. So in the meantime, I'll show you, I'll go back here. You see that this particular infrastructure is completely deployed. And the infrastructure as code, we have deployed the VPC, the networking components. We have deployed the stateful components, that is database and container registry. We have booted the EC2 server. We have prepared the stateful instances by pushing a dump, which you will be doing with the help of migrations, and a Docker image to the container registry, and then a deploy application part, which is getting executed right now. So now if I go, I'll quickly, in the meantime, because this is a time-taking process, because it will do all the update and upgrades on the server. So now what I'll do is I'll quickly help you go through the Ansible docs. So you can see if it's present for any and I'm so sorry. Any and every type of cloud provider that is present. It's present for Amazon AWS, and the documentation is very verbose. And every type of resource you can, create using AWS modules. Say we go to DigitalOcean modules. You see there's a community supported DigitalOcean module also present. So if you want to say a domain info, we need to create a domain, or you need to create an DigitalOcean database, you can go inside. And you can also see some live examples present here, which you can use, and also what kinds of values you need to pass. So fairly simple. You don't have to write some JS functions or anything. You simply need to write a YAML file with the particular key value pairs, and your infrastructure will get deployed on the cloud provider. So now if I come back, I'll go to my VS Code. I'm still installing a few things. We'll have to wait, guys. In the meantime, I'll show that nothing is actually running on the server right now. I'll do 3000 here right now. You can see that nothing is here. Maybe /nots. See, nothing is getting loaded. Now it's installing the Docker engine. You can see that everything is deployed right now. I'll quickly check this on the server. If I go to root, because I've executed all the commands as a root user. Now I do a Docker PS here. You can see that the Docker container is up and running. To verify, we'll go back to my browser and we'll hit the endpoint. You can see we are just running a get query and we are getting the information back from the database. The hello world, simple, a root route, a health checkpoint point. So now we have seen that we have deployed an entire end-to-end application, and also we have done a configuration management on the server and did a very basic Docker deployment. Now, few assumptions that I made is to keep this simple is that I have assumed that whatever servers we'll be booting will be an Ubuntu 22.04 server only, but Ansible has the ability to identify what kind of server it is, what kind of OS distribution it is, and then run commands based on the roles that we had. So we have given the demo for configuration management and deployment, and then the advantages of Ansible. To reiterate, as I said, that we have found one tool that helps us manage both our infra and configurations. It's very easy to learn and understand because all you have to do is write roles, tasks, and playbooks and all that in YAML format, just key value pairs. It's present for all different kinds of operating systems and cloud platforms in the industry. And you can create reusable roles and components. For example, what I did here was the DigitalOcean part. So you can have a separate role that deploys your infrastructure to DigitalOcean, but the deployment part of your application can again be reused on that particular infrastructure. So the roles are pretty much reusable. So this was pretty much it from my end. I hope this will interest you into, trying and learning Ansible. It's very easy. You don't need to, learn much about DevOps to implement these things, but simply writing of YAML files, and you can go ahead and boot up your infrastructure and code and make all those deployments way simpler. And we'll also try to make some parts of this public so that, developers can use it to boot up simple applications for testing and stuff. And also do reach out to us if you want to, collaborate on this thing. We'll love to, work on this. And if we look at the future plans of Ansible as to what we are trying to do, in the next 6 months or so, we are trying to, create Ansible roles for all the major cloud service providers and all the different kinds of deployments it does, including Kubernetes and moving to, maybe a cloud provider like Hetzner or a VM infrastructure like OpenStack and OpenNebula. So we'll be trying and adding all those roles so that we have a common practice in the DevOps team and throughout the organization that one particular deployment goes in a particular way and the deployment is relatively faster. We'll just change the WAR files and we'll go ahead and deploy that.